But over the internet, especially if it's free, I can reach the whole planet, right? This is YouTube. It goes everywhere, the whole planet, literally. I mean, I look every day. I have a look at which countries are hitting my website, deGarisMPC, and it's literally the whole planet. Well, China not, but the proxy server using Chinese tend to use American and Canadian proxy servers, so they do get the stuff indirectly. And what are the major? Well, obviously the English-speaking countries are the main ones who hit it regularly. So far and away top the US, and then Britain, proportionally more from Britain, the UK, Germany, Scandinavian countries, Australia, Canada. Yeah, they're the main ones. Okay. Now another remark before I get on to the details. I've mentioned in previous sessions, a few sessions back, that I'm getting close to finalizing the selection of the texts and courses I will give at PhD level, PhD 1 and PhD 2. And I noticed that the proportion of the texts, particularly PhD 2 level, the really advanced stuff, it's too much physics, not enough math. And I'd like to keep a fair balance between the two, so I've decided to incorporate a bit more math at PhD level to give a bit more balance, including the odd computer course. Now I'll show you one text. I'll put in at PhD 1 level. It's just called Computability. The author is Tourlakis, sounds like a Greek name, George Tourlakis, and it's a fair. Well, here's my finger for comparison. It's a fair thickness, about just 400 or 500 pages, I guess. Yeah, about a bit over 500 pages. I'll put that in PhD 1 level. It's PhD level computability theory, and we are now in this course at M1 level, pretty much, in the part, 3 parts in the text on computability. But this PhD level goes into detail the work of Turing and Gödel and various others like it, Kleene and Post and so forth. So Gödel's theorems are treated in detail, which is fascinating. And I may put in some set theory, like the continuum hypothesis of Cantor, the famous Cantor, German logician, mathematician, who pioneered the notion that there are different kinds of infinities. There are different levels of infinities. They're like the positive integers, the countable numbers, 1, 2, 3, 4, ... There are an infinite number of those, obviously, but that kind of infinity is a lower kind of infinity than the number of real numbers. And Cantor showed in a famous proof, the so-called diagonalization method that we'll actually do in this course. And Turing also used the same method, an ingenious method. Anyway, it was pioneered by Cantor, George, I think, Cantor, German, to show that the infinite number of real numbers is a different kind of infinity, sort of a larger infinity than the infinity that is used to measure the number of integers, or positive integers. Okay. Anyway, Cantor is also famous for talking about the continuum hypothesis. And what he meant by that was So the type of infinity you use for the countable numbers, call that kind of infinity LF ALEPH. Don't worry, it's just a label. L of 0. Okay, and the infinity that you use to count the number of real numbers, call that L of 1. And the continuum hypothesis says essentially there's no other kind of infinity between, sort of a larger kind of infinity than L of 0, but less than the kind of infinity of L of 1. Okay, there's nothing in between. And so this book goes into that. Set theory goes into it. Gödel worked on the continuum hypothesis for quite a bit, especially in the 40s. And so I may put in some set theory that deals with this kind of stuff in PhD level, because it's the foundations of mathematics, right? Logic and set theory. People, Bertrand Russell, for example, believed that set theory was the basis of mathematics, and wrote these tomes trying to prove that was the case, till Gödel comes along and just destroys it. And then Gödel himself works on the continuum hypothesis and something else related called the axiom, A-X-I-O-M, axiom of choice. And the axiom of choice and the continuum hypothesis related. Anyway, if you like the foundations of math, and it's very abstract, it's PhD level for sure. You may love these extra courses that I'll pop in at PhD level to sort of balance out that it's not too heavy on the physics, particularly string theory. So just as interest, I'll give you. You won't be able to see it, but in my right arm I have a pile of books. I'll just read out some of the topic titles, give you a taste for what I'll put into the PhD level, more or less, math side. So smooth manifolds, Morse theory, division algebras, finite groups by Gornstein, the main player in the classification theorem of finite simple groups, advanced algebraic geometry, exceptional Lie groups, super manifolds, I don't know how to pronounce it, never heard it pronounced, K-A-C, cache, I don't know, Kac-Moody algebras and their representations, infinite dimensional Lie algebras, Moore and algebraic geometry, algorithmic topology, classification of 3 manifolds, and random matrices. So that should balance. Just a minute. That should balance things out a bit. Let's see, any other remarks? Yes. Those of you who've been following my earlier courses, you may have noticed a doubling of my productivity in the sense of the number of video clips I'm now uploading per day to YouTube. It's now around 8, 10, 12, that order, typically around 8. And that's because I found a trick with YouTube to increase the upload speed, and that is simply, if I have let's say 8 video clips, typically 10-12 minutes each, to upload, I will open the window to YouTube. I'll open 8 windows, and in each one I will upload 1 clip, and they all go through in 2-3 hours, 2 hours, but in parallel. So like 8 times. So the speed, before I'd have like a queue, waiting line. But learning this trick, I've now increased the speed of upload to YouTube so that it's no longer an issue. So now what is an issue is like the next bottleneck, and that is the pre-processing time. And it takes me, for a day's filming, which is nearly 2 hours, it takes me about 8 hours, to pre-process. So the next step I'm thinking of, maybe I can double my productivity on the pre-processing, is to have several computers doing the pre-processing, because the pre-processing is offline. Right? I don't need the internet for that. I just need, well, for example, Microsoft's Movie Maker, and it modifies the pixels in some way. I don't know, increases the contrast or something. I'm not quite sure what's going on. And I can add titles, and I can cut the raw movie film, well, file into pieces and so forth. So by having a second computer, now I have an old laptop that I'll try to revive. I haven't used it for a couple of years. So I'll put Movie Maker on that, and I can then halve the time. So I can go from 8 hours to 4 hours. And that'll have an impact on my day, because I'd like to be working during the daylight, also for my eyes. But when I have to spend about 8 hours pre-processing, I won't go to bed till about 2 or 3 a.m. to finish all this stuff, and that means I have to get up. I get up later, so I get less daylight. So I want to shift hours back. I suppose I could just bite the bullet and wake up earlier than my body wants, but then I get tired. So anyway, expect changes in the speed at which I can pre-process, and I'm toying with the idea. I don't know how practical it will be yet, but if I can really knock down the pre-processing time, the upload time to YouTube is no longer an issue, right? I just do all that in parallel. So if I can pre-process also in parallel on several machines, or just find a more efficient way to pre-process, like with Movie Maker, I have to go through it like twice, which is tedious. There may be more efficient ways just to pre-process. So if you know of ways, please suggest. Please email me and point things out. I'm toying with the idea of literally doubling the number of boards I do a day. Instead of 1, go to 2. Because, for me personally, the most fun part of all this is writing up the whiteboard. Because that's when I learn. Like, if the stuff is somewhat new,